So in a multi-tenant environment, what is multi-tenant environment? Multiple customers, different VRFs, multiple control plane, multiple service routes. Each customer routing table have got set of service routes, customers route, customers destination networks. We have multiple customers, we have multiple routing table, multiple set of service routes, but sometime there may be a need for you to take the service routes of one customer and provide it to another customer. Or sometime you may want to take the routes, the internet routes, and provide them to customers. In all these circumstances where you want to take the routes of one control plane and give it to another control plane, take the service route of one VRF and give it to another VRF. We do route leaking between VRFs. Yeah. So not only in Cisco environment, though it is written as Cisco, this is Cisco training, we do this leaking whenever we use MPBGP. We can do through MPBGP this leaking stuff, or you can also statically, by writing static route itself, you can mention the VRF inside which this route need to be appearing. Yep. So we are going to discuss different options available to do route leak between VRFs. So the best method is this: use MPBGP to do this leaking. That is the best. That's what it is written in the first paragraph, second point, the last line. The recommended method for full dynamic inter VRF communication is MPBGP. So let's see method 1 using MPBGP. Whenever you don't want to use static routes, route leaking between VRF, recommended is to use MPBGP. Obviously it is route target that is going to play a vital role. So this method involves configuring BGP to be aware of different VRF using route distinguisher and route target to control these service routes, to decide which service route are imported and exported between VRFs. We know what is route distinguisher and route targets. To refresh, I have written here, route distinguisher is a value that is prepended. I showed you in Juniper, it was very clearly shown that prepended, not added at the back. Route distinguisher was prepended in the front of your prefix, prepended to the prefix, to make it unique within the BGP table. So if multiple customers have got same subnet, again it is not going to be considered as the same subnet. The reason is the prepended value for each customer is going to be different. route distinguisher is different. So along with the route distinguisher value, each prefix is 96 bit. So your 32 bit may be same with a different customer, but when it is prepended with route distinguisher, it's no more same, because it's not just 32, it is 96. That first prepended 64 bit is not the same for every customer. Route target, which is nothing but the community, BGP community attribute value. It's a tag, it's a value which BGP uses as the community values, the tag values. We learned once upon a time BGP community. We know how the tags are used, and when the tag is matched, how the actions are taken, like setting local preference or wait or MED. Here the same tag value, route target, the BGP community value, decides with whom the service route need to be replicated, advertised, distributed. So the other VRF configured to import the same route target value will install those routes into their own routing table. So it is the route target that decides what route to be installed into the routing table. Alright, though I have written here it as iOS XE because iOS XE is what mostly we see in service provider, not the iOS, but these commands are also same for iOS. Here we have two VRF. VRF A with the route distinguisher 1:1, VRF B route distinguisher 2:2. VRF A is exporting the routes using the extended community value 10:10. And you can see VRF B is downloading it. On the same router. See, the leaking happens between VRFs. This is not on the different router, my friend. Usually the export of this router should match the import of the another P router. That's normal layer 3 VPN. Here we are talking about leaking the routes between the VRF. A is exporting it and B is importing it. This is another control plane, another customer. And B is exporting with 20:20 and A is importing it. Alright. So this VRF A imports 10:10, which is coming from the remote site. It is also importing the routes of another VRF on the same router. Similarly, it imports the remote site route plus it imports another VRF route. In this way, the routes are leaked. How easy? Route leaked between two VRF on the same router. Right? So then we go to BGP, enable BGP and define the address family that we all know. And then you may have some network to advertise. You can say redistribute connector, redistribute static. So whatever you have advertised here using redistribution or through network command will be available to VRF A remote site as well as VRF B remote site. The reason is the route target. In the previous page we saw the route target. VRF A export is imported here. Understand? VRF A has got some set of connected interface. VRF B have got different interface, different set. Now they both are now merged because of route target on the top. Similarly, for VRF A you may have one static route. For VRF B you may have another static route. Because of the route target, import and export value on the above to VRF, this static route is available for that VRF static route is available for this VRF, as well as the connected. So routes within the VRF need to be injected into BGP process so either you use network statement to advertise them, or as you saw in the previous in the above example, you may use the redistribution. All right, that's it. So control with route map, you see, if you do not want to advertise all the prefixes to the other VRF, then you may write a route map, write access list, match some prefix and call that under the route map, and then add the route map when you redistribute. So use route map with a prefix list to filter specific prefixes rather than leaking all routes, which can help to prevent routing loops and maintain control. In case, if two customers have got same prefix, you do not want to advertise those prefix which they may conflict or form loop. So you can filter by using route map. Alright, so those things you can add when you say redistribute connected and then followed by route map. Alright, so this is one nice example. Using BGP, we do leaking between VRF. I'm going to quickly show this demo, then we will get into another example with static route. Let's go to the lab now. R9, this is going to be 1111. Interface loopback 0, IP address 1111. Right, let us do router BGP 30. Network. Will this get advertised? No. Network. Because on the interface I have masked it with 32, I should put mask. Alright, and then what? I also want to advertise (11) under BGP, so I say network. For this I no need to put mask because the default is /8. Show IP BGP, I should see show IP BGP, I should see these two networks. Okay, now going to router 1. Oh no, I made a big mistake. No, I did not make mistake. Go to router 1. Okay. So here I'm going to remove the OSPF which I created for the customer with the process ID 2. So I say no router OSPF 2. That's the VRF OSPF removed. What is next is I'm going to say interface F1/0. IP address is 11.001. Okay, next is router BGP 100. Address family IPv4 VRF. I don't know the name that I gave, so do show IP VRF. Okay, the VRF, the name is KFC. So going under address family IPv4 KFC, IPv4 VRF KFC, and I'm going to say you got a neighbor called 11.0.0.111. Remote AS is 30, and I'm expecting a neighbor now. Ping using VRF KFC 11.0.0.111. Okay, then why I didn't form neighbor? Oh, I gave 11 here. It should be 11.0.0.111. Okay. Okay, now I'm expecting neighbor. Show IPBGP. Show IPBGP summary. Oh, I didn't configure neighbor here. Router BGP 30. Your neighbor is 11.0.0.1. Remote access 100. Okay. So I'm expecting neighbor now. Oh, we got a neighbor. KFC. Blah blah. What else? We got a neighbor with this, right? Okay. Now I want to see the VRF condition. Show run section IP VRF. I'm going to remove this VRF kacha kacha because it is too kacha kacha. Meaning I'm going to remove these targets. That's what I mean. Okay, there is no route targets. Show IP BGP. Sorry, show IP VRF detail. VRF for VRF KFC. Show IP VRF KFC detail. Brief. KFC stuff. Okay, here's the KFC. And if you see in KFC, you don't see any route targets. Cool. Similarly, I also want to remove This customer BK, I don't want it to be customer BK, I want to make it as BK West. So I'll say no IP VRF customer BK. This is a confusing thing. So I removed. Do show IP VRF. Okay, so why it is having star, it is getting deleted. I also want to delete internet. We'll see later. Internet stuff. Okay. Now I'm going to say IPVRF BK West RD 1:1, and then I'm not giving any route targets. We'll come to that one. Before, I would like to go to F01. And then I say IPVRF forwarding, you belong to BK West. And then I give the IP address, which is 100.0.0.10. This is it. And we are going to now router BGP 100 address family IPv4 VRF cust BK VRF BK West BK West, and then I say neighbor is 100.0.0. I think I gave one there on the customer side. Remote AS is 10. And what else? That's it as of now. So let's bring this west now. Now once the router comes fully up, I will find a neighbor. Go to R1 and look for another neighbor. Show IP route BK VRF BK West. Okay, as of now I see only the connected network. Once the neighbor is established with BK West, I should be learning that 110.0 100.100.100 network. BK West is still getting booted. BK West, no console. Let's get the console. Yeah, I already see a neighbor now. So go back to the edge router R1 and look for the route. Still no route. How come? BK West. I can see a neighbor, but show IP BGP. They're supposed to advertise these networks. I'm expecting. Okay, I got the route. So BK West has got this route and listen very carefully. BK West route is up here. This is what called a service route of that customer. Is appearing in the routing table of the customer's route VRF, the control plane of the customer. Similarly, KFC West. But show IP VRF. Oh, simply KFC. Okay. Okay, listen carefully. These are the two routes. Um, this is coming from the Burger King, and this is coming from KFC. I want this to appear in Burger King and 110 to appear in KFC. I repeat, if I'll go to KFC routing table, show IP route, as of now I am not learning any routes. So if I want to reach Burger King from KFC kitchen to Burger King kitchen, because in KFC there is some shortage of chicken, I want to get it from the kitchen of the Burger King, which is very next door, so that I can manage with my customers. So how do we do that? Leak the route. I should see that 110 network here in KFC, 110 is from Burger King. Similarly, I want to see that 111, which is KFC, in this routing table of Burger King. For that, let's do this. Route linking. IP VRF KFC. And I'm going to export route target export. For this special purpose, I'm going to use the special number. Special number to export 1030. I export. Oh, not allowed that big number. Okay. 130. What? Okay. Sorry. 1030 colon 30 10. Cool. So this is the value I'm exporting. For this purpose. What purpose? Merging between this KFC and that Burger King. But for the remote office Burger King, I am going to use different route target to export. That will be plain and simple 1:1, so that guy will import. In fact, for that I know I want to have the same value for import also. See, between the same customer site, I don't want to mess with the import and export. That's useless. It is useless to use different route targets between the sites of the same customer. So I use same 1:1. I will also do the same thing on R4 when I'm configuring under VRF BK East. But this one is only for the VRF between these two on this site. We are not merging these two fellows. No, we are not merging these two fellows. Our aim is to merge these two. So for that I have a special route target. This is what I'm going to use to import there in KFC. Hey, what am I doing? Sorry. I have been a big mistake. I'm right now inside the KFC. And I'm exporting this. So I repeat, with this KFC, I would like to use not 1:1, I'll use 2:2. Otherwise, I'll get confused later. For KFC, because I created this as a second VRF, I don't want to use this 1:1. I'll use 2:2. So route target 2:2. Now let me make it clear for you. Show run section IP VRF. You can see that there is one export, and that is going to be an import in Burger King West. So going to Burger King. Hey, go to Burger King IPVRF. And then you say route target import, that one which we export here in KFC. By doing this, I am leaking the route of KFC into the Burger King. And as usual for this guy, we have route target to the branch offices, both import and export as 1:1. Now, whatever the Burger King exports, I want to export it using route target export 3010:1030. This I will import in the KFC. Route target import 3010:1030. That's all. We have already leaked. Let me make it clear for you by typing this command. You see, whatever I export here, whatever I export here, I import here. Same number. Whatever I export here, I import here. This is to merge between these two sites of different customer. But why do I have this one? That is for my remote sites of the same customer. Alright, now I'm not really going to on all this router 2, router 3, router 4. For today's class, it's not necessary. I just want to show you that between the KFC and Burger King, the routes are available. You see now? I'm showing you the routing table with 110.100, which is the network of Burger King West, and 100.0.0.0/8, which is the network of Burger King WAN facing interface. Likewise, if you go to KFC West, you can, if you go to Burger King West, you can see the routes of KFC here. So if I want to ping now KFC, I'm able to ping. These are of two different customers. We have merged two different customers' head office, KFC head office and Burger King head office. Branch office, they are not going to be merged. Our aim is to only to merge the head office. Now, use the same technique. This is the homework to bring the internet to these two customers. There is no other Kambasustram available. Same Kambasustram what I used now. Don't depend on me to do this internet thing. Create another VRF. Bring internet service to these two customers' head office. Once you're done, I will check, and then only I'll do the static thing, which is going to be our next topic. Alright, I'm giving you a very easy homework. This method too I'll do after you finish showing me the internet routes for these two customers following the same methodology which I used to merge the routes between these two head offices. Alright, also make sure that PK East and KFC East ping internet through the head office. Through the head office. Did you understand the homework, or if you have any question, ask me.